So some more examples on series resistors and parallel resistors. Now let's look at this circuit. Let's say we have a circuit given like this. We have a 10 ohm resistor, 20 ohm resistor, and we have a 30 ohm resistor like this. How can we simplify this one? And here you can see we have 10 ohm resistor and 20 ohm resistor in parallel, I mean in series. So if they are in series, we can add them together. 10 plus 20, that's going to be 30. So the equivalent circuit is going to look like this. You're going to have 30 ohm resistor right here, and then if you add them, this is also 30 ohm resistor. And when we have equal resistors in parallel, equal magnitude resistors, equal value resistors in parallel, it's only work for two resistors. The equivalent resistor is going to be half of this. So this is going to be the final equivalent resistor. We can say RT or R equivalent is going to be just 15 ohm resistance. Now let's look at another example. Let's say we have a circuit given like this. Okay, so this is 10 ohm resistance, and this one is 20 ohm resistance, and this one is 60 ohm resistance. And let's say this one is 10 ohm resistance, this one is 20 ohm resistance, and let's say this one is 30 ohm resistance. And here you can see these three are in series, 10, 20, and 30. If you add them together, that's going to be what? 10 plus 20, 30, 30 plus 30, that is 60. So the equivalent circuit of this one is going to look like this. We are going to have 10 ohm, and then we have 60 ohm here, and then the 20, and whatever we are adding in series, like 10 plus 20 plus 30, that is 60. That's going to be parallel to this 60 right here. So whenever we have equal resistors in parallel, whenever we have two equal resistors in parallel with the same value, the equivalent resistor of that one is going to be half of that. So here we have 60 and 60. The equivalent resistor is going to be 30 ohm resistor. So we are going to have 10 ohm, 30 ohm, and then 20 ohm. 10, 30, 20. Now finally all of them are in series, so we can add them together. So 10 plus 30, that is 40. 40 plus 20, that is 60. So the total resistance is 60 ohm resistor. Okay, now let's look at a complex problem. Okay, let's say we have a circuit given like this. A long circuit, and here we are going to have some resistors. Okay, so let's put a one resistor here, here, and here, and then here, and then here, and then one here, one here, and then one here, and one here, and also one here. Okay, let's put all the resistors. Let's say this is 30 ohm resistance, and let's say this one is 5 ohm resistance. Let's say this one is 15 ohm resistance. Let's say this one is 5 ohm resistance. Let's say this one is 30 ohm resistance. Let's say this one is 40 ohm resistance. Let's say this one is 50 ohm resistance. Let's say this one is 20 ohm resistance. Let's say this one is 30 ohm resistance. Let's say this one is 20 ohm resistance. Okay, now how can we simplify this one? The better way we can do is we can look from the end, and here you can see we have these two are in series, these two are in series, 15 and 5. So we can add them together. And if I draw the equivalent circuits after I add them, that's gonna look like this. But okay, I have to do it anyway. Let's do it. So here we have, you know what, this is a parallel circuit for these two things. So I can also draw this one like this as well. It's the exact same thing. Now we have added this 15 and 5, that is 20. I put it right here. And then we have 30 ohm resistor, that is right here. And then we have 20 ohm resistor, that is right here. And then 30 ohm resistor right here. And then we have here, we have a 5 ohm resistor. And we have a 20 ohm resistor. And this is a 40 ohm resistor. And this one is a 30 ohm resistor. And this one is a 50 ohm resistor. Now you can see these two are in parallel. So I can do product over sum. Like when we are dealing with two resistors in parallel, I can use the product over sum. Product over sum is 30 times 20 divided by 30 plus 20. So 30 times 20 is 600 divided by 30 plus 20, that is 50. 50 times 12 is 600, right? 12 times 5, yes. So 12 is the equivalent resistor for this one. So if I redraw this one, this is gonna be 30 ohm, 40 ohm, 5 ohm. Then we have 5 ohm here, 30 ohm here, 20 ohm here, and then 20 ohm here. And then the equivalent resistance we just found out, that is 12. Okay, let's look at the next one. So we have 12. This is equivalent of these two. Product over sum, 30 times 20, that is 600 divided by 50, that is 12. Okay, we got the 12. And then here we have 20 here, and then we have 30 here, and then we have 5 here, 20 right here, and then 40 right here, and then 30 right here, and then 5 here. So here we have 20 and 12. These are in series, so we can add them together. That's gonna be 32. Instead of redrawing again and again, I'm just gonna modify this circuit. Okay, 20 plus 30, 12 is gonna be 32 right here. So I erase this one and put a 32 right here. 32. Okay, it comes from 20 plus 12. Now we have this 32 and 30 in parallel, so we can do the product over sum. 30 times 32 divided by 30 plus 32. 30 times 32 is what? Let me calculate this. 30 times 32. That is 960. 960 divided by 62. Divided by 62, that is 15.5. Things are getting weird. I should have done this one in a better way. Let me erase the whole thing and redo it again. Redo it. Instead of solving the circuit like this, I'm gonna actually draw the exact same circuit in a different way. Okay, let's draw this one in a different way. So this is 30 ohm, keep it as it is. And this one is 40 ohm, keep it as it is. And 50 ohm, keep it as it is. 5 ohm, I'm gonna just adjust the end of this circuit. So 5 ohm, and then we have 30 ohm, 20 ohm, Okay, let's keep it until this, and let's try to simplify the whole circuit. So here we have 15 and 5, that is 20, 15, 5, 15 and 5 are in series, so that equivalent resistance is going to be 20, because if it's in series we can add them together, so that's going to be 20 right here. So the equivalent resistance here is 20, and then here we have 30 and 20 are in parallel. 30 and 20 are in parallel. Okay, 30 and 20 are parallel, so we can do the product over sum, because this is only two circuits. So 20 times 30 divided by 20 plus 30, that is 600 divided by 50, that is 12. Okay, so 12 is the equivalent. After we got 12, we can redraw this one like this: 12 here and then 20 here. That is 32. 32 parallel with 30. 32 parallel with 30. Product over sum: 32 times 30 divided by 30 plus 32. That is 960 divided by 62. That's what actually I found out. That's 15.5 here. And then okay, the 15.5 is right here. And then after that, these three are in series. 15.5 plus 5, that is 20.5. 20.5 plus 20, that is 40.5. 40.5 and 40 are in parallel. So 40.5 times 40 divided by 40 plus 40.5. Calculate it. 40.5 times 40.5 40.5 times okay, 45 points times 40, that is 1620. 1620 divided by 80.5. Divided by 80.5. That gives approximately 20. So let's put it as 20 right here. So the equivalent of these two parallel is 20. So finally we are getting 20 plus 30, that is 50, because finally all of them are in series. So 20 plus 30 is 50. 50 plus 50, 100. So the total resistance of this circuit is 100. Okay, and that's how we can do this problem. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.